All right, guys, we are back to chapter 9, right, for the CCNA journey. Chapter 9 covering spanning tree protocol concepts. So we went over what convergence looks like in regular spanning tree, right? Um, Now we need to go ahead and talk about, be a little bit more granular and talk about what convergence looks like in regards to in a working state and a non-working state. Okay. So one of the things we need to talk about is what's the activity look like whenever the network, right? And we're still speaking from a layer two standpoint. Whenever the network remains stable, right? So whenever the network remains stable, right, the root switch generates a new hello BPD, right? So we've got past the point of convergence, right? The elections are done, right? And so now we're in a working state and we want to go ahead and pass frames, right? So the root switch is going to send a new hello BPDU with the non-root switches forwarding copies of the hello so that the hellos traverse the spanning tree. Okay. All right. So the root is going to generate a new hello every hello time. Okay. And we're going to go into the discussion about timers shortly. Okay. So the root is going to generate a new hello BPDU every time, right? Every 2 seconds, right? Every default 2 seconds. Um, that's the default values for the hello timer. Okay. Each non-root switch, forwarding those hellos out of any interfaces in a forwarding state after updating the hello. Okay. Again, right? The root is going to send out a hello, right? A hello BPDU, right? Every 2 seconds, right? Every time that hello timer hits that value. So what I mean by that is, hey, it's 2 seconds, send a hello. It's 2 seconds, send a hello, right? 2 seconds equals up to 200 milliseconds, right? So it's going to send that every 2 seconds. That is the default value. Okay. Following that, the non-root switches are going to go ahead and send that as well. Okay. All right. So if you guys looking at the screen, you guys will see the key topic. Um, okay, he's saying mic issues. Okay. If you guys see the key topics, this is basically what I went over and what you guys have to remember. Okay. In the working state, okay, step one, the root creates a and sends a hello BPDU with a root cost of 0 out of all of its working interfaces that are in a forwarding state. Okay. Step two, the non-root switches receive the hello BPDUs on their root ports. Okay. After changing the hello to list their own bridge ID, has their senders BID, and listing the root switch's cost, the switch forwards the hello out of all of its designated ports. Okay. All right. And now, right, step three, steps one and two, repeat every hello time until something changes. Okay. So step three is very important. This is going back to what I was saying earlier, right? That hello timer exists on every switch. Okay. Hello timers, the default value is every 2 seconds. Okay. Every 2 seconds. So this process is going to continue in a working state until, right? Until we don't receive hellos. Okay. Let's talk about these timers here, right? So we spoke about a hello timer. Let's talk about the max age, right? The max age timer, it's 10 times the hello, right? It's 10 times the hello timer. Okay. 2 times 10, 20. You guys got that. All right. How long, right? The max age is how long any switch should wait after ceasing to hear hellos before trying to change the spanning tree topology. Okay. Let's talk about forwarding delay. Forwarding delay, the default value is 15 seconds. This is very important. The forward delay is a delay that affects the process that occurs when an interface changes from a blocking state to a forwarding state. Okay. A port stays in an interim listening state. We're still talking about spanning tree here. Okay. So for those that probably read ahead and probably thinking, hey, what about rapid spanning tree? We are talking about spanning tree, okay? So a port that stays, and we're talking about forward delay in regular spanning tree. A port that stays in an interim listening state and then an interim learning state for the number of seconds defined by the forward delay. Okay? Listening state, 15 seconds. Learning state, 15 seconds. Okay? All right? So it's exactly what you guys think, right? If the switch doesn't get an expected hello BPDU within, let me get my pencil, okay? If the switch doesn't get a hello BPDU, right, within this time, okay? If it doesn't get the hello BPDU within that hello time, that hello max age time, okay, the switch is then going to react into taking the next steps into changing the spanning tree topology. Okay. Again, default settings. Hellos are 2 seconds. Max age is 10 times the hello, right? So 10 times 2. That means the default value for the max age is 20. Okay. So if the switch goes 20 seconds without hearing a hello, it's going to go ahead and react, right? So what happens after, right? We're now in a broken state, right? And the switches are not, right? Are not hearing a hello BPDU, right? From that from the root switch, okay? Right? Or any switch in that matter. After that happens, right? After the max age expires, the switch essentially makes all of its spanning tree choices again. So everything that we went through, that we talked about, right? In spanning tree convergence, election process, et cetera, et cetera. It has to do all of that again. And it's going to do that, right? It's going to do that convergence in the election process based on the hellos it receives from other switches, right? What it's going to do, it's going to go ahead and the control plane, right? That CPU within the switch is then going to reevaluate which switch should be the root switch based on the hello BPDUs it has, right? In its spanning tree process. Okay, right? If the local switch is not the root, it chooses its root port, right? It's going to go through that process. It's going to choose, hey, I got my root port. I know what my designated port is, or my blocking port, et cetera, right? Then it's going to go through the process of spanning tree convergence. Okay. All right. Let's talk about this diagram so it can make sense. Okay. Let me pull this up. All right. So let's talk about convergence from the working state to the broken state back to the working state, right? So we have switch one, switch two, switch three. This should look familiar. We went through this before, right? Switch one is a root switch, right? And so in this scenario, right, what happens, right? What happens is we have switch three, gigabit 0/2, right? It's in a blocking state. We established that, right? It's in a blocking state, but in this scenario, right? Switch one, let me get the pencil. Switch one's gigabit 0/2 interfaces fail. Okay. So now what happens, right? Switch three's root port isn't receiving hello BPDUs from the root. So now switch three's, right? Switch three's a CPU, a control plane, it's now counting on the max H, right? It's waiting on, we're going to assume for this diagram, because we can't see any configurations, we're going to assume for this diagram, it is waiting 20 seconds, right? That time passes, right? That max age timer passes without hearing hello. Once we get that, right, and we have an interface that failed, right, the switch is going to assume this that hellos is not going to be arriving on that interface anymore. Okay, so this is out of the picture, that connection. Okay, so now switch three can act, right? Switch three can go ahead and say, excellent. Now I need to go ahead and start reevaluating my spanning tree, right? Right? Even though this is a blocking port, okay? Let's go ahead, cut this, right? Because this is our cut cable, right? Maybe some rats got to it, they ate it, but this is not part of the topology anymore. So now what does switch three do, right? Switch three starts to reevaluate, right? Because we still need to send out frames. We have end users connected to us, right? So we still need to forward frames, right? So it's going to start reevaluating, right? And what you guys learned in the previous section, right? The two previous sections, apologies, is that even though gigabit 0/2 on switch 3 is still in the blocking state, right? In regards to forwarding frames, okay? Forwarding frames. That does not mean it is not receiving BPDUs, okay? It is still receiving BPDUs from switch 2. That is the only traffic that's allowed, right? That is how spanning tree can work, right? So now that we're in a broken, in regards to switch 3, okay, let me say it the right way. Now that switch 3 is in a broken state to where it cannot reach its root bridge, okay? It's going to go ahead and receive those hellos from switch 2, right? Has forwarded from switch 1, right? Switch 1 still has a lower bridge ID than switch 3, right? Then, boom, switch 3 is going to go ahead and say, hey, gigabit 0/2, you are my root port, okay? So once we have that, right? Oops, excuse me. Once we have, that's the wrong button. There we go. Once we have that, right? Right? It's going to go ahead and evaluate the root calls that it received from switch 2, right? It changes to its new root port. Now we have a new spanning tree. Now Bob, right? Bob that's connected to switch 3 can now, continue watching his YouTube videos. Okay, right? But that process that, of convergence that it has to go through from going from the working state, non-working state back to the working state, right? What's happening is, you know, along with the control plane, the data plane is having some changes as well, right? And what's happening is we're having a change within the interface states. Okay. One thing I need you guys to remember for your exam is there is a difference between the spanning tree, right? Spanning tree interface states, spanning tree interface roles. Okay. Let me give you an example. Roles, root port, that is a role. Designated port, that is a role. Okay. States, forwarding, blocking, listening, learning, that is a state. Okay. All right. When spanning tree finally converges, right, after, going through all of its selection process, right, a switch chooses a new port roles, new port states, right? And those port roles determine the port state. I'm going to say it again. The port role determines the port state. You will need to remember this for the exam. Okay. So switches use, right, spanning tree, right? They can go ahead and move immediately from a forwarding state to a blocking state, right? Um, and that's immediate, right? But in the reverse, it takes a bit of time to go ahead and transition from the blocking state to the forwarding state. I am talking about regular spanning tree. I'm not talking about rapid spanning tree. I'm going to say that again. Okay. So if we're looking at this diagram, right, and we see gigabit 0/1, let me get my pencil. We're looking at gigabit 0/1, and we see, right, it has a root port role, right? And of course, we know a root port role, you guys learned within your studies, is always in a forwarding state. After convergence, gigabit 0/1 might need to be a root port or a designated port. The switch will immediately say, hey, I'm going to put you in a blocking state. Once once I finally start to perform spanning tree convergence again, right? I'm going to put you in that state. Okay. Now, whenever a port that was formerly blocked, okay, let me go ahead and erase this so it can make sense of it. Look at switch 3 now, right? When a port that was formerly blocked needs to transition to forwarding, the switch first puts the port into two intermediate interface states, right? Why? Okay. These two intermediate interface states, right? They help right, prevent temporary spanning tree loops. Okay, we have listening and we have learning, right? I want you guys to take a look at what that is. Um, okay, right? So listening, right? Listening, like the blocking state, the interface does not forward frames, right? The switch removes old, stale, unused MAC address table entries, okay, for which no frames are received from each MAC address during this period, okay? These stale MAC address table entries could be the cause of temporary loops, right? Why is that the case? It's because if we're looking back at figure 9-7, right? We had a change in the topology, right? We have to converge, we have to cleanse, right? Our switch from remembering what's connected to what, because a change happened at layer one, okay? Right? Let's talk about the learning, right? The learning state, right? The learning state interfaces in the state still do not forward frames, but the switch begins to learn MAC addresses of frames received on the interface, okay? All right, so spanning tree moves an interface from blocking to listening, then to learning, then to forwarding, right? All right. Um, Spanning, right? An interface that's operating in regular spanning tree, right? In each state's, right? And for each state, right? For a time equal to the forward delay, right? Which defaults to 15 seconds. Okay. So listening, learning, 15 seconds each. Okay. Right? As a result of this convergence event that causes an interface to change from blocking to forwarding requires 30 seconds to transition from blocking to forwarding. In addition, right, to a switch might have to wait for the max age timer, right, to finish before choosing to move an interface from a blocking state to a forwarding state. So essentially, adding in the max age timer, right, we essentially right for um interfaces port state, right, and port role to change may take roughly 50 seconds. That's adding, right, the going through, if we're talking about regular spanning tree, going through the different the spanning tree port states and adding in the max age timer. Okay. All right. Okay, we talked about this before, right? Summarizing the different interface states for spanning tree. Okay. What I want you guys to do, I want you guys to go ahead, whether you have Packet Tracer, whether you have your own lab, please lab this up, understand what this is. Um, Talking about earlier sections that we covered within the chapter, please be able to draw a topology and write out, right? Do convergence with your hands, okay? Understand priority, understand the entire bridge ID, understand the election process, then come to what we just covered now and make sure you make this muscle memory. This is going to aid you for your exam, and I need you to understand this before we move to dynamic routing protocols, okay? All right, guys. Thanks for joining. You guys have a great day.